Hello everyone. Again, for some reason in the last video, I skipped over slide 21, which was probably the one where you would have the most questions. So it's funny that I skipped over that one. So we're just going to go through this slide, which is a couple questions. It does take a while. So it's what it is it's how do you solve equations using identities? And I think it tells you which identity to use in each one. So we're just going to jump right in. The first one says use a double angle identity to solve this cosine squared minus sine squared equals 1/2 in the interval 0 to 2 pi. So that 0 to 2 pi just means give any answer in radians because it's 2 pi from the unit circle. You don't have to worry about general solution stuff. So double angle identity. If we go back to this unit circle chart, we didn't do double angle formulas, but it's still pretty straightforward. So if you notice our question said cosine squared minus sine squared. Well, that's this right here. Cosine, because the a can just be x, right? Cosine squared x minus sine squared x. So we can see that that equals cosine 2x. So that's nice because when we solve trig equations, we like it to be only one trig function. So we can replace our cosine squared minus sine squared with just cosine 2x. And now we know, hopefully, if you already watched the other video, that you can't touch that inside stuff till after you go to the unit circle. So you say, okay, where on the unit circle is the cosine value 1/2, which would be at pi over 3 and 5 pi over 3. Remember, we want radians because it's 0 to 2 pi. And so you set the inside of the parenthesis equal to pi over 3 and 5 pi over 3, and now you have to solve this for x. So you would divide by 2, which dividing by 2 is like multiplying by 1/2. So hopefully we're all, if you do keep change flip, I just couldn't really show that when I was typing, but you can think about it as keep change flip, and you end up doing multiplying by 1/2. And then when you multiply fractions, you just multiply the tops and bottoms, and you get pi over 6, and over here you would get 5 pi over 6. So those would be your two answers. Oops. Okay, and you'll just type that in here and put submit. Question 2 says use sum and difference identities and get an answer between 0 and 360. So now that means you just want to use one time around the unit circle, but you want it in degrees. So sum and difference identities are these formulas. So I try to color code this to kind of help clear it up. So why is this helpful is because it can kind of break up this x plus 45. And you're going to see that things cancel out. At first, you don't feel like you need it, but you would kind of get stuck trying to solve this without it. So let's do what they said and see if it helps. We're going to replace x plus 45. So it's like a is your x and 45 is your b. So sine of x plus 45 becomes sine x times cosine 45 plus cosine x times sine 45. So that's what I did here in red. And then you have plus sine of x minus 45. So it's the same thing, but now you're using the second formula because it's minus. So you replace sine x minus 45 with sine x cosine 45 minus cosine x sine 45. And then it still equals -1. So if you notice here now, if you combine like terms, we have sine x cosine 45. I'm pointing again like y'all can see that. This first term and this first blue term are the same, and it's positive and positive. So if you have two of the same term and you're adding them together, it's two of them. So 2 sine x cosine 45. And then this second red term is the same as this second blue term, but it's negative. So those would cancel each other out, right? The positive and a negative term cancel. So you're just left with 2 sine x cosine 45 equals -1. Well, then go ahead and replace. We know, because that's not a variable. Cosine 45 is a number. So we can go ahead and get what number that is. That is, if you look on your unit circle, go to 45 degrees, the cosine value is square root of 2 over 2. So now I would go ahead and multiply this outside front 2 by this square root of 2 over 2. Well, this 2 and this divided by 2 cancel. I can't highlight very well in here. So you're left with just, oops. You're left, oh my. Now I don't even know what's happening. Oh, gosh. I just tried to do undo, but it's not letting me undo. I don't know. I just ruined this, but there you go. Sorry. I was trying to do too much. So basically this 2 and this over 2 would cancel. So you're left with just square root of 2 times sine x equals -1. And then we divide by the square root of 2 to get sine alone. And so then you have sine x equals -1 over square root of 2. But then we rationalize that. So we multiply the square root on the top and bottom. And you end up with negative square root of 2 over 2. So then you ask yourself where on the unit circle is sine negative square root of 2 over 2, which would be at 225 and 315. And that's your answers you type in there. Okay, this one says use a half angle identity and a Pythagorean identity to solve this equation and in the interval 0 to 2 pi. So it wants it in radians. Okay, so this one's kind of a lot. So I put the half angle formulas here and your Pythagorean identity you're going to use here on this right side. We didn't use half angle identities, but you should know how to use a formula. If this equals this, and they can be replaced, right? So now I feel like I'm missing. I'm just a mess, y'all. Okay, never mind. So this is your original equation. 2 minus sine squared equals 2 times cosine squared of x divided by 2. And so they tell you to use a half angle identity. On your test, you don't use a half angle formula, so don't worry about this on your test. But I just wanted to make sure y'all understood this example. When you're squaring a trig function, you can rewrite it like this. So I put or, and then I rewrote it to where that's really what it means if it's cosine squared. It's cosine of x over 2 squared. So now I put it in red. Cosine x over 2 is right here. And then that equals plus or minus the square root of 1 plus cosine x instead of a divided by 2. So I replaced it with the half angle formula. Well, now if I'm squaring a square root, that cancels. And also if you're squaring a plus or minus, it doesn't really matter whether it's plus or minus. When you square a number, it becomes positive. So we can drop the plus or minus, and then we can also square the square root and it's gone. So you end up with just 2 times 1 over 1 plus cosine x divided by 2. Well, then the 2 times and the divided by 2 would cancel. So you're left with just 1 plus cosine x on the right side. So now let's look at the left side. I'm noticing other red, that's wrong. So it said use Pythagorean identity. Because remember, when you do a trig function, when you solve a trig equation, you want it to be one trig function. So if you notice, we have sine over here, cosine over here. We don't like that. But we can replace sine squared with 1 minus cosine squared because of the Pythagorean identity. If you move the cosine squared over, which I put it in this box over here. So I did that in red because I want to make sure that you put it in parentheses and distribute that minus sign. So it becomes 2 minus 1, which is 1, and then minus negative becomes plus cosine squared equals 1 plus cosine. Then if you notice, we have a squared cosine and we have a not squared cosine, so we're going to have to factor. So you move everything over to the left side. So you subtract 1 on both sides and those cancel out. And then you subtract the cosine. So you're left with cosine squared minus cosine. So how can you factor that? Well, it's not a trinomial, so you don't need X method, but you can factor out what they have in common, which is cosine x. And then you're left with your 2 factors, set them equal to 0, cosine x equals 0, and cosine x minus 1 equals 0. Solve them for cosine. So just add the 1 on this second factor. And then you go to your unit circle and you say, okay, where is cosine 0, which would be pi over 2 and 3 pi over 2. And where's cosine 1, which would be 0. So you have 3 answers. Okay, one more is use a double angle identity to solve cosine 2x plus 2 sine squared minus sine x equals 0 in the interval 0 to 360. So we want our answer in degrees for this one because it's 360 degrees. So if you look at your double angle formula, I know we hadn't looked at this before, but they give you 3 different things that cosine 2a or 2x could be replaced with. So you could use any 3 of these to replace this cosine 2x. So how do we choose which one we want to use? Well, remember, we only want our trig equation to be in terms of one trig function. So the rest of our trig function is in terms of sine. So we want this to be in terms of sine. Well, first option is cosine squared minus sine squared. That's not in terms of just sine. The second one is in terms of sine. The third one is the one that's in terms of sine. So we're going to choose that one. So we replace that. We don't really need parentheses because there's nothing in front of it to multiply. So we replace cosine 2x with 1 minus 2 sine squared x. And then we see that we have a negative 2 sine squared and a positive 2 sine squared, so those cancel. The second term and this third term. So you're left with just 1 minus sine x. Now to solve that, I would suggest doing plus sine x, so you have a positive. You could subtract 1 and divide by a negative if you want to do that as well. But you end up with 1 equals sine x. So you say, okay, we're in a unit circle. It's the sine value 1, which is only at 90 degrees. So your answer is 90 degrees. And then you can evaluate. So that is slide 21. That's pretty challenging. It's just practicing using identities in solving. I don't believe there's one on your test where you have to do that, but I could be mistaken. I can't remember. But nothing like that. And there's nothing where you have to use a half angle. So even if you see one that looks like this, you don't have to. I did an example at the end of the other video showing you why you don't need to use that. I think if you need to use one, they'll let you know. That is that. Let me know if y'all have any other questions or if I skipped any other slides and didn't notice. And good luck.